Hmm. Hmm. Okay, hello guys. In this live stream, we are going to discuss like what are the possibilities we can travel faster than light. I will be reading a book chapter, nothing else, and exploring what is happening, what is not in the current scenario. So let's start. Okay, so let's start reading chapters. Let me open the book first. And I'll be writing whatever the findings, outcomes, I'll be writing here only. Okay, so no need to worry. Like I'll be writing all the points here only. Okay, so let's start. So the book says here, the chapter name is Faster Than Light. It is quite conceivable that light will eventually spread through the galaxy and beyond. So light may not forever be unimportant trace contaminant of the universe, even though it is now in fact. So the author is saying like life is a contaminant of universe. Hmm. Life is a contaminant of universe. It is impossible to travel faster than speed of light and certainly not desirable as one hat keeps blowing up. It is some uh, philosophy at the start of chapter. In Star Wars, as the Millennium Falcon blasts out the desert planet, carrying our heroes Luke Skywalker, and Han Solo, the ship encounters a squadron menacing Imperial blastship orbiting the ship. Imperial battleships fires a punishing barrage of lasers blast at our hero's ship that steadily break through its force fields. Millennium Falcon is outgunned. Whatever this. Let's jump to the right part. Hmm. So basically, the author is saying that light travel is light faster than light. It is a science fiction. It is science fiction, like we have seen in movie, right? See, according to Einstein, the speed of light is the ultimate speed limit in the universe. Even our most powerful atom smashers. So he's talking about Large Hadron Collider CERN laboratory, which can create energies found only at the center of exploding stars, or the Big Bang itself, cannot hurl subatomic particles at the rate faster than speed of light. Apparently, speed of light is the ultimate traffic cop of the universe. In any hope, our see, the author is saying that our our strongest instruments, or what to means our advanced instruments, so powerful enough, create energies equivalent to Big Bang, cannot cannot swirl the atoms faster than speed of light. Okay, thing is, like, see, what they do at the sound laboratory, they keep, let me show you some picture there. Sound laboratory. So we what the hell? Sound laboratory laboratory provider. So what they do actually is you see here, no? You see the cylinder, you see tubes, right? So what in tubes what they do? They keep spinning electrons inside the tube or faster, faster, faster. Every time electrons completes a revolution. Like what happens actually is like see this is tube, right? So our electron is here. Every time it completes a revolution, it gets faster. It gets faster. So the question is why doesn't not get faster than speed of light? Like if you keep accelerating the electron, why does not it gets faster than the speed of light? That's the question here. So our current instruments are showing that you cannot get faster than speed of light. You cannot. Because after pouring that much energy, we are not able to cross the barrier of speed of light. So how can we hope to travel galaxies which are like billions of years of light away? Never. Right. That's what the author is trying to say here. That if so, any hope of our reaching distant galaxy seems to be dashed. So finding this is a failure or mm, finding this is a failure or what we can say achievement. I don't know, but it's an achievement. It's an achievement. The failure is on the part that through space we cannot travel. Through space. But the thing is through wormholes we can travel. I think the author will address in the later part. Okay, so let's start reading more. And the next topic is Einstein and the failure. What is Einstein and the failure? Einstein. Einstein. This is so weird. Einstein. Einstein and the failure. So let's say what the author has to talk about it. I'm going to read it. In 1902, it was far from obvious that the young physicist Albert Einstein would be hailed as the greatest physicist since Isaac Newton. In fact, that year represented the lowest point in his life. 1902, the lowest point in his life. I know, I don't know. A newly minted PhD student, he was rejected for a job by every university he applied. He later found that his professor Heinrich Weber had written horrible letters of recommendation for him, perhaps in recommendation for Einstein having cut so many classes. So, thing the author is saying that Einstein professors, what he did, he wrote horrible letters of recommendation for Einstein. That's why in 1902 he cannot get a job anywhere. The reason is that Einstein have cut so many classes of him. So understand now, if you know everything what a professor is going to teach, what is the reason to be there in the class? So that's why he left so many classes. So that's why he got a horrible recommendation letter. Mm. Furthermore, mother was his girlfriend Mileva, who was carrying his child. Uh, Okay, their first daughter Lizelle would be born illegitimate. Okay, Einstein and his girlfriend. Okay, I don't know where the book is heading. Let's read it. Even his lowly tutoring job abruptly ended when he was fired. So Einstein was a tutor. Einstein was a tutor. Einstein was a tutor. Hmm. Also, Einstein was a tutor also. Hmm. He even wrote to his family that perhaps it would have been a better if he never born, since he was a burden to his family and lacked any prospect for success in life. When his father died, he felt ashamed that his father had died, thinking that he is was a total failure. So Einstein is saying that when his father died, he was ashamed because his father think that he was a total failure who would be keeping family responsibility ahead. What a story. Yet later that Einstein's luck would turn. A friend arranged for him a job as a clerk in the Swiss patent office. So friend arranged him a job. That lowly position, Einstein would launch the greatest revolution. From that position, Einstein revolutionized the world. Yes, and we live in that revolutionized world. What a story! And we think like nobody knows this kind of thing. That's why you need to read books. Yes, and we live in that revolutionized world. What a story! And we think like nobody knows this kind of thing. That's why. Okay, okay, let's continue. I was just checking if the voice is good or not, you know. So, okay. So, that what happened is that he got a job in the patent office, right? So, what happened now that Einstein, when the patents came to Einstein, Einstein was analyzing the physics patents so that he could learn. Ah, what was this? What was the secret? Perhaps one clue to his genius was the ability to common food. So the author is saying that why was Einstein a genius? Because his ability to imagine clocks, accelerated, what his imaginative power. Einstein was able to imagine clocks and trains. Einstein was able to imagine clocks and trains. Clocks and trains. That's why he would. That could be success of his secret of his success. Hmm. Let's jump ahead. Okay. Then in this part, author was trailing that Einstein was a failure initially. Then he rose up from the ashes to the absolute peak of success. Now let's dive into Einstein and relativity. So the next thing is Einstein and relativity. Einstein and relativity. Relativity. So let's start. Albert Einstein proposed his celebrated special theory of relativity in 1905. So 1905 was the year he proposed his special relativity. At the heart of this theory was a picture that even children can understand. His theory was culmination of a dream that he had since when he asked faithfully he knew that Newtonian mechanics studied the motion of objects on Earth and in the heavens. And Maxwell theory described the light. So these are two pillars. So the thing is that when Einstein was studying physics, there were two pillars of physics. One was Newtonian mechanics, and Maxwell wave equations. Maxwell wave equation. Okay. Well, the essence of Einstein's genius was had his recognized one prediction was thing is Einstein recognized that what he recognized that these two were the pillars of physics at that time. Okay. So he somehow recognized that one of them is wrong and had to fall. Now let's see how he did it. According to Newton, he could always outtrace a light beam because there was nothing so special about the speed of light. So Newton thought that light is made of particles. That corpuscles theory Newton had. Nothing very special about light. You can always run faster than light. That's what Newton is telling. Newtonian mechanics tells. So let me write Newtonian mechanics. Newtonian mechanics tells that you can run faster than light. So, hmm, no one had ever seen a light wave that is totally still. I guess it is frozen. Finally, a college student during studying the Maxwell found the answers, but even Maxwell didn't know the speed of light was constant no matter how fast he moved. If you could raise the light, you still let me read. Okay, let me read. See, start. Hmm. According to Newton, you could always outtrace a light beam since there was nothing special about the speed of light. This means that a light beam must remain stationary as you raced alongside. But as a youth, Einstein realized that no one had ever seen a light wave totally stationary. I don't think Einstein realized this. Author is just saying something else. Okay, let's ignore that. Finally, as a college student in Zurich studying Maxwell's theory, Einstein found the answer that he discovered that even Maxwell didn't know the speed of light was a constant or not. I don't know why Einstein was thinking that speed of light is a constant in the first place. So the whole point of the relativity theory is that speed of light is constant. It is the whole point. In vacuum, it is constant. It never changes. So then Einstein is saying that Maxwell didn't know that speed of light was a constant. No matter how fast you moved, if you race towards or away from a light beam, it still traveled at the same velocity, but this trait violates common sense. You can never magazine always away from you at a constant speed, no matter how fast you move. So the thing is, really see, I'm going to draw something. Like here you are, okay, and here the light is traveling. So if you're traveling at speed like half of the speed of light, like c by 2. Wait, let me draw. Like c by 2. Okay. And light is traveling with c. So you think that relative velocity is c by 2 relative velocity, but that's not the case. The relative velocity is still c. Relative velocity is still c. That's what here the author is saying. But Newtonian mechanics was a tightly constant system, like pulling on a loose thread. The entire theory could unravel if you made the smallest change in its assumption. In Newton's theory, the passage of time was uniform throughout the universe. Our second on Earth was identical to a second on Venus and Mars. Similarly, the meter stick placed on Earth had same length as meter sticks on Pluto. But if the speed of light was always constant, no matter how fast you move, there would be there would need a major shakeup in our understanding. But the whole point, Einstein somehow realized that in speed of light is constant no matter how fast you move. See, I Einstein betted on his theory, I guess. He take a bet like this is true, I guess. Then what he did, then he theorized his theory. So that's what he's saying. That if the speed of light is constant, then whole relativity that Newton suggested is false. Because if the speed of light is constant, then you are saying now that relativity breaks. Newtonian relativity breaks there. According to Einstein, if you were inside a rocket ship, the passage of time inside that rocket would have to slow down with respect to someone on Earth. someone on Earth, time beats a different rate depending on how fast you move. So time passes on a different rate how fast you move. Time passes on different rate how fast you move. Passes on a different rate how fast you move. And why why does it happen? I hope author is gonna answer it. Let's see. Why time passes differently? Hmm. Okay. Time will pass slowly, length will decrease, length will decrease, and mass will increase if you traveling fast. If you travel faster, time will slow down, length will decrease, mass will increase. So mass will increase. Let me check. He's saying right. At the as and the Mars rocket, if you prefer to peer into the rocket without telescope, you would see the clocks inside rocket running slowly, people moving in slow motion, people would appear flattened. In fact, if the rocket were traveling at the speed of light, time would apparently stop inside the rocket. The rocket would be compressed to nothing, and the Mars would be influenced. None of the observations make any sense. Nothing can break the light barrier. So the thing is, I don't know. Somehow Einstein imagined. How did he imagine? I don't know. But somehow imagine that if you travel at the speed of light, length will decrease to singularity, mass will increase to infinity, and time will stop, and nothing makes sense. So we cannot travel at the speed of light. If you travel at the speed of light, length will increase to zero. Length zero, mass infinity, mass infinity, and time stops. He first imagined before theorizing theory, he imagined this, and that's why he says that it doesn't make sense. I don't know how he reached to that conclusion. Let's see. Because Einstein said it, because an object gets heavier the faster it moves. That means that the energy motion is being converted to mass. Precise amount of energy turns into mass is calculate. See the C line. Hmm. Okay. That will happen if you travel the speed of light according to Einstein. Okay. That will happen. Since Einstein derived his famous equation, literally millions of experiments have confirmed his revolutionary idea. For example, within a the GPS system which can locate your position on Earth within a few feet would fail unless one added correction of relativity. Since the military depends on GPS, even Pentagon generals have also briefly have to be briefed by the physics concerning accurate relativity. The clocks on GPS actually change as they speed above the Earth. The thing is, like You know about GPS system, right? GPS system. GPS is like this is your your Earth. Oh, this is your Earth. Here satellite, and from satellite on Earth, it is doing GPS. Satellite is traveling very fast. Satellite is traveling very fast. So the time it is traveling fast, so time will pass differently for satellite. That's why theory of relativity will be applied so that GPS can locate your location. Theory of relativity should be applied. Okay. Hmm. See, the most graphic illustration of this concept is found in atom smasher, in which scientists accelerate particles near to the speed of light at the gigantic CERN accelerator, the Large Hadron Collider, Geneva, Sweden, and protons. See, the thing is, author is telling, like in the particle accelerator, we accelerate the particles at the speed of light. So we have to use theory of relativity over there. To rocket scientists, the light barrier is not much a problem. So rockets are built every thousand. Okay. They're saying that rockets do not use relativity because they are traveling slightly slower. Now let's talk about author will tell the loopholes of relativity. What are the loopholes? Loopholes in Einstein theory. Let's see what are the loopholes that author is saying. Hmm, loopholes in Einstein theory. Loopholes. Over the decades, physicists have tried to find loopholes on Einstein's theory. Some loopholes have been found, but most are very not useful. For example, if one sweeps fast flashlight across the heavens, in principle, the image of light beam can exceed. In principle, the image of light beam can exceed the speed of light in few seconds. The image of flashlight moves from one point to another on the horizon to the pose of edition at stretch of 100 light years. There is no importance or no formation can be sufficiently okay, see what the hell is saying. The image of light beam can exceed the speed of light. What? Let me internet reason right. Image of light beam. Image of light beam can exceed the speed of light. How is it possible? So think is, if light travels in a different medium, then light in vacuum will be faster than that speed of light. I think it is saying that hmm, if we have a pair of scissors point at which the blades cross each other moves faster than from the joining point, light year long, the crossing point can travel faster than speed of light. Again, because crossing point carries no energy information. Pair of scissors can exceed. Array, what the hell is? Pair of scissors can exceed the speed of light. pair of scissors can exceed the speed of light. What they are telling? If they have right shape, the contact point can indeed move faster than light. Scissors almost at the speed of light. Pairs of scissors. Hmm. So you're saying that if you have a pair of scissors, if you close at the speed of light, the edges will travel at faster than speed of light. Then he's saying again this is of not importance since crossing point contains no energy or information. Yeah, so it is saying that there are some things which can cross the speed of light. As I mentioned, like why is as I mentioned a chapter for EPR experiment able response light to EPR experiment. Okay. Yes, when we recall it, two electrons vibrating in unison in their centric speeding in opposite direction, cause this the coherent information can be seen one level serialization from the random and useless. Seeing the things we can do stuff faster than speed of light, but it is all useless thing. The only thing like in we are doing useless thing. We cannot send information at the speed of light. That's what the author is trying to say. In principle we cannot do, we can move faster than speed of light, but how can this happen? So the electro so what I'm saying is like if something is moving faster, if something is able to move faster than speed of light, then thing is something is made of atoms, so atoms can travel at the speed of light, so atoms will be have infinite mass. Hmm. So I don't know what I was trying to say here. So let's see. Hmm. What feels now the author will tell why Einstein found a loophole himself. How Einstein found a loophole himself. Now author will tell that. Okay, let's see. Okay, let's see. I will be back in 1 minute. To physicist's most important loophole came from Einstein himself. Most important loophole came from Einstein himself. Okay. So let's start. Yes. Okay. Let's start. Loopholes in Einstein theory. Scissors traveling faster than speed of light. Scissor EPR paradox. EPR paradox is literally just if you entangle two electrons, they can they can send information. Like they can exchange anything faster than speed of light. Like if one electron is up, one electron is down. If you put one electron down, other will be suddenly up. So this process is happening faster than speed of light. But what the author is saying that nothing useless is happening, nothing of useful is happening. So if something can break speed of light, so how the theory is correct? Like I'm not saying that useless. Any- Anything is happening, right? Is it useless or not? Anything is happening. So the Einstein theory is incorrect. Like something can break speed of light. I think author is drunk. Say to this. Okay. Hmm. To physicists, the most important loophole came from Einstein himself, who created the general theory of relativity in 1915, a theory that is more powerful than special theory of relativity. Seeds of general relativity were planted in Einstein when Einstein considered a children merry-go-round. As you saw earlier, objects shrink at the speed of light. The faster you move, the more you squeezed. But in spinning disks, outer circumference move faster than center. The center is in fact almost stationary. This means that a ruler stick placed on a rim must shrink when a ruler placed at the center, nearly the same. So the surface of merry-go-round is no longer flat but curved. Thus acceleration has effect of space time. The thing is, I think the point here is if you travel at the speed of light now, see, if you travel at the speed of light, so see, here we're traveling at zero speed, at the speed of light. So the thing is, you will shrink to this size. Okay. So the thing is, Einstein is saying that you will not shrink. You will not shrink. Space which is carrying inside, which has a taking you, like is the space in which you are will shrink. So as a result, you will shrink. So nothing will happen with your body at the speed of light. Hmm. You know what I'm telling? Hmm. In general theory of relativity, in general theory of relativity, space-time is a fabric. Let me understand this once more time. like he is saying that uh, here is center of merry-go-round and here is periphery. So the objects here are traveling faster than the center, right? So the thing is, here the objects will appear slightly smaller because they are traveling faster. Okay, so how that can happen? Yeah, space should shrink. Space will be curved. No longer flat. So the same surface of merry-go-round is no longer flat but curved. Acceleration is effect of curving space-time. Acceleration can affect the curvature of space-time. So let's see. So acceleration can affect the curvature of space-time. Acceleration, acceleration can affect the curvature of space-time. Every time you study this, you get more these theories because we didn't made them. If we have made them, we got a clear idea what is and what is not. So, but every time you study this, you get more confused. Nothing else. Thing is, gravity makes the curvature of space-time. If you're traveling at a faster speed, you will appear small. So the space will be curved accordingly so that you appear small. So the space is curved. What do you mean by curved space? Seriously, you mean? Hmm. In general theory, space-time is a factor that can stretch or shrink. Under the certain circumstances, the fabric may stretch faster than speed of light. For example, Big Bang, universe was born in a cosmic explosion 13.7 billion years ago. One can calculate the universe was originally expanded at the fastest space. So the author is saying that Big Bang expansion rate initially was faster than the speed of light. But the objects in the universe was not moving at the faster speed of light. The stars, the space between stars that was expanding, not star themselves. So the stars was not moving. Star was not expanding at the speed of light, but the space is expanding speed of light. So space can stretch faster than speed of light, or it can squeeze also faster than the speed of light. So if you want to travel faster than the speed of light, then squeeze the space. Then squeeze it. Like here is one point, here is one point, here is 2 points, 2 light years away. Below two. Then the what? Don't do anything. Just squeeze it, just crush the space. I think that's what wormholes are. We are crushing the space. We are just crushing it. Expanding space does not carry any information. So thing is, matter cannot go at the speed of light. Matter or any information cannot travel faster than speed of light. Thing is, hmm, information cannot travel faster than the speed of light, and we are information. Our body contains information. That's the whole point. The important point is that special relativity applies only locally. That is near the university. That's what I'm saying. If you want to travel faster than the speed of light, just squeeze the space. The space can expand, space can squeeze faster than speed of light. But any information cannot travel faster than the speed of light. That's what my conclusion till. Any information cannot travel faster than speed of light. So let me write the point. I will start live stream once again, but I will end it with this point. Any meaningful information cannot travel faster than speed of light. But space can be excluded. Space can be squeezed faster than light. Faster than light. So in theory, we can travel. We can travel. Okay, in theory we can travel. So I'll end the stream for right now. I will start again after some time, like after maybe 2 hour and 2 hours. So you can join at that time. Okay. So bye for now.